This challenge is called Operation Orchid. It's a medium-level challenge from the forensics category from the picoCTF 2022 event. The description says, download this disk image and find the flag. Note, if you're using the web shell, download and extract the disk image into your /tmp directory, not your home directory. And then we have a link for the compressed disk image. So the first thing we want to do is we want to right-click on this link and select Copy Link Address. After we've done that, we can go over to the web shell and we can create an environment where we can solve our challenge. So the first thing we want to do is we want to create a directory inside the /tmp directory. I'm going to call my directory ... the shy hat, just so nobody can find it. So not that we're really worried about that, but if we're creating directories in the /tmp directory, we probably want to make them hidden. And then we can enter that directory. And then we can download the file using wget. So it's going to be wget and then space, and then paste in the file address, and then hit enter to download the file. So after it's downloaded, we should see this .gz file in our current directory. So this is a gzip file, and in order to use the contents, we need to unzip it. So we can use the gunzip command to unzip the file. And after it's done, we have this disk.flag.img file in here. So this is a disk image file. So if we run the file command on this file, we'll see that it is a mbr boot sector file, partition 1. So what we can do is we can start using some forensics tools from the sleuth kit in order to examine this file. So we're going to clear the terminal, and then what we're going to do is we're going to use mmls on the file, which is going to return the disk partitions in this particular image. So when we do that, we're going to see that there are 3 potential partitions we can look at. There's a Linux partition over at offset 2048. There's a potential Linux partition over at 206848. And there's a third Linux partition over at 411648. So these are the offsets we need to feed to the different sleuthkit tools in order to do our enumeration. So the next thing we're going to do is we're going to do our file ls, and we're going to do this on the different partitions. We need to supply the offsets for these partitions. And what this is going to do is it's going to get the file contents of these partitions. So this first one for the partition at offset 2048, let's do this. So we see here that there's not very much here, just a few files. And then we're going to take a look at the same thing for the partition at offset 206847. And it says that cannot determine the file system type. So we're going to ignore that one. Next, we're going to take a look at the other offset, the other partition at offset 411648. And we see that there are a lot of different directories in here. So most of the time when we're looking for flags inside of these digital forensic CTF challenges, we want to look at the root directory over here. So the root directory's inode is 472. So what we're going to do is we're going to do the file ls on that particular inode. So it's going to be the same command as before, only this time we're going to supply an inode, which is 472. Okay, so in this inode we've got 3 files. We've got the .ash history, we've got the flag.txt file, and we've got the flag.txt.enc file. So this is probably an encoded file because it has this file extension right here, .enc. And we've got this flag.txt file, but it probably does not actually have the flag inside of it. But we can take a look at the different inodes with the icat command. So the icat command is going to let us read specific inodes at different offsets. So we're going to do icat with the offset 41, 16, 48, and we're going to supply the inode of 1876, which is the flag.txt file. So we might as well take a look at this one first. So I forgot to supply the name of the disk image. So let's supply the name of the disk image. Okay. All right. So when we take a look at the contents of flag.txt, it is not here. So that is so it's probably the situation where the flag.txt file was deleted or otherwise modified. So we can't rely on that. We can also take a look at the flag.txt.enc file, which is probably an encoded version of the flag, and that's going to be at 1782. 1782. Okay, so let's take a look. So it says salted, and then it has a bunch of characters over here. So this is probably an encoded flag. So how was it encoded? So the answer lies in the third file that we want to look at, which is the .ash_history file, and that's located over at inode 1875. So when we read this file, we get the console history for this particular partition. So we made a flag.txt file with the touch command, and then we modified it using the nano command, and then we used OpenSSL to encode the flag using this command right over here. And then we used the shred command to delete the flag.txt file. So because we have access to the encoded version of the flag, we can actually decode the flag using OpenSSL with the opposite operation over here. Okay, so the first step to doing that is to read the flag encoded file, and that is icat at the node 1782, but we're going to redirect that into a file called flag.txt.enc. So this is going to create a file in our directory, which we can then decode. So after we've done that, we see that flag.txt.enc is in our directory now. So what we can do is we can run the opposite operation with OpenSSL in order to decode the flag. So we're going to run OpenSSL in AES-256 mode, in decode mode, with assault. We're going to input flag.txt.enc, and we're going to output flag.txt, and we're going to supply the key unbreakable password 12345667. When we run this command, it's going to give us some warning messages, and it's going to tell us that it was a bad decrypt. But error messages don't necessarily mean the operation didn't go through, because when we take a look at what's in our directory here, we see the flag.txt file, and when we read the file, we see the flag is here. So all we need to do to complete the challenge is to highlight the flag, copy the flag, then go over to picoCTF. In the challenge description here, we're going to paste in the flag and then click on Submit Flag. And then we're done.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.